Introduction. Is time universal or subjective? Much like an electron exhibits properties of both a wave and a particle, time appears to possess both universal and subjective aspects. This exploration aims to delve into how our experience of time is deeply subjective, even while acknowledging its universal framework. Today I want to share my thoughts on how I feel time is subjective, even though it's universal in nature. Focus. It might seem counterintuitive, but focusing intensely on time often makes it feel slower. Our perception of time often operates inversely to our emotional state. Happiness makes time seem to fly by, sadness or depression stretches it. In all these cases, emotion plays a major role in our perception of time. My analogy? Imagine two friends A and B studying in the same class. A loves math, while B loves history. For A, math class seems to fly by, but for B it drags because he doesn't like it. However, B's history class goes faster than A's. If we shift perspective to other friends, the results are the same. It depends on how much they like or have an interest in it. Even from the teacher's perspective, their experience of time in different classes might vary. What if we look at it from someone outside the classroom? If they're waiting eagerly, time still feels slow. This doesn't imply time itself is subjective. Rather, it highlights that while time operates within a universal framework, our individual experience of it is profoundly subjective. Think of it like Coke. It's universally known to be sweet. But the amount of sweetness, sourness, and so on is completely different for each individual. The universal sweet is like time, and the amount of sweetness is like how each individual experiences time. Heart of time. Change is at the heart of time. Time is inseparable from space-time. Time cannot be active or act without change. Even if time exists, it needs changes to be observed. We measure time through changes. Consider a train moving from station A to station B. If the train doesn't move, we can't measure anything. When it moves, we can measure time. As the perception of these changes can be subjective to an individual, we cannot expect universality in the experience of time. We can consider change as representing dynamics and energy, which depends on space. Time is intrinsically linked to change, energy, and space. These are inseparable. If we want to understand more deeply, we have to understand the objective aspects of time, as described by physics. Time dilation. Gravitational time dilation. Time dilation does occur due to gravity, as described by Einstein's theory of general relativity. Clocks run slower in stronger gravitational fields. Since mass creates gravity, a more massive object exerts a slightly stronger gravitational pull on its immediate surroundings by curving spacetime. The concept of relativity itself pertains to the frame-dependent observations within individual frames of reference. Let's consider an analogy. A person A, who is 100 kilograms, and another person B, who is 50 kilograms. When comparing their experience of time, one might ask if the time for A, T_A, equals the time for B, T_B. Surprisingly, theoretically, T_A does not precisely equal T_B, as slight variations of time between them exist due to their differing masses. However, in a practical sense, the difference is tiny and negligible. The tiny additional dimple we create on the trampoline of space-time by our individual mass is dwarfed by the massive sag already caused by the Earth. While our mass, whether 50 kilograms or 100 kilograms, theoretically contributes a microscopic amount to localized spacetime curvature, this effect is overwhelmingly dominated and effectively rendered unmeasurable by the massive curvature created by the Earth itself. So for the question of whether a 50 kilograms person experiences time differently from a 100 kilograms person at that specific instant, the practical difference in their experienced time is immeasurable and negligible compared to the time dilation caused by Earth's gravity, but a difference does exist. If we want to see practically observable time dilation variations, one would have to at least reach near light speed or experience extreme gravity like that near a black hole. Even though this theoretical difference makes time more interesting, this idea helps us look at time as geometrical. It even helps us to imagine time invisibly, making it visible in a fabric or sheet where every dip created by their mass influences time. Time and experience. If time is a geometric dimension, why do we experience it so differently, unlike a square that appears consistent to all observers? Consider a hypothetical scenario with two individuals, red and blue. Red is in a spaceship traveling near light speed, while blue remains settled on Earth. Both red and blue are born on the same date and time. If on Earth, blue joins school for first grade and then after 1 Earth year moves to second grade, red in his ship would also experience 1 year passing for him and move to second grade in his own reference frame. For both, 1 hour feels common within their respective frames of reference. However, upon red's return, the impact of time dilation becomes clear. red would be significantly younger, while blue would be older. For example, if red is 20 years old upon return, blue might be 50 years old, despite them being born at the same time. Red would have only 20 years of lived experience and memories, while blue would have 50 years of experience. This highlights how, despite the geometrical variations in space-time, our internal experience of time maintains consistency with our own biological aging. Red, being 20, does not have 50 years of memories or biological changes. His experience is entirely consistent with his 20 years of life. Time dilation is observed when comparing different frames, not felt internally within one's own frame, because all internal processes, including memory formation and aging, slow down proportionally. We experience life and time through changes. Experience shows us that time, as we perceive it, is beyond purely geometrical descriptions. Experience is never the same. Even with a single cup of coffee, each sip is a distinct and unique moment. Conclusion: ultimately, the paradox of time lies in its dual nature, a fundamental dimension woven into the fabric of space-time, yet also a profoundly personal journey shaped by our emotions, perceptions, and unique frames of reference. When we observe the universal nature of time, we do so through observable changes. For instance, the growth of 1 hour always takes 1 hour within your own frame of reference, regardless of your speed. Yet even when we acknowledge the shocking subjectivity of time, we still observe it through changes, our unique and evolving experiences. This interplay of the universal and the subjective makes time one of the most enigmatic and deeply personal aspects of our existence.